Once again, very good morning and hearty welcome to all the faculty participants and our today's resource person, Dr. Arun Chauhan. In this day 5 sessions of AICT RGPV 1 week online teachers training program in the broad domain of applied natural language processing. In this forenoon session, we have Dr. Arun sir, who is working as assistant professor in Department of Computer Science and Engineering at Indian Institute of Information Technology, Dharwad. Before joining here, he was working with Department of Computer Science and Information Systems at BITS Pilani, Rajasthan. He received his PhD degree from Computer Science and Engineering Department at IIT Roorkee. He received his MTech degree from the School of Information Technology at IIT Kharagpur. He has also been to IBM Watson Labs at IBM Bangalore for his research work on the recommendation systems using microblocks for duration of 1 year. His broad areas of interest are data mining and machine learning. I heartily welcome Arun sir for this teachers training program, and I am very much thankful for sharing his valuable time as well as valuable resources, as you have been to very prestigious institutes always during your academics and professional career. So your presence is an asset to this TTP. I request you to take over the mic and start the session. Thank you.
Yeah, good morning, madam. Good morning, all faculty. I'm really thankful to such a wonderful opportunity you have provided to me. So,
are you getting the sharing? Yes.
So is my screen is visible?
Yes, sir. Perfectly visible.
Okay, fine. So today I want to discuss what is LDA, latent dirichlet allocation. It's a probabilistic topic modeling technique, and then I will just discuss one paper which I have worked using LDA, and try to give you insight how you will be using, how you can use this LDA for your own work, right? So that is the theme of this. So first I will go theoretically in first few minutes, and then later once we get adapted with the intuition. My idea is not to give you very core mathematical derivation of this, but to get familiar of like what is LDA and how you can use it for your work, right? So intuition is it is one of the thing that I want to provide it here. So in topic modeling, right, this topic modeling is like a statistical modeling technique where you want to find out how many topics are there in a collection of documents. So for an example, if I give you 100 newspaper and I ask you, like, can you find it out what are the different topics that have been discussed in these 100 newspaper? So namely, if you just go by layman term, you read all those papers, and based on your prior knowledge, how you classify the things, whether you want to classify Sachin Tendulkar as a sportsman or like a Rajya Sabha member that is part of a politics. So it depends like on your prior knowledge, how you want to classify your given text into different topics. So in topic modeling, in general sense, you want to find out how many topics are available in the collection of documents, right? So in this, because it is a statistical technique, so there will be no name of topic. So for example, this latent dirichlet allocation modeling technique will not tell you like the people have discussed politics in it. It will tell you in abstract that this is a topic one, where a lot of times these words have been used, and the words are Rajya Sabha, Lok Sabha, election. So by that you can infer that because these words are grouped under this topic, so obviously this topic one will belongs to some politics thing, right? So topic numbering will be abstract. It is not like us how human beings understood the things. but this abstraction will give you a good idea when you, for example, you will see parts related to the sports in nature, you will see wildlife, river. So likewise, these topics will be uh, grouped. These abstract topics. Some topics will also be it's a parameter how you will how topics you want to find it out, right? So it's under documents will be provided, and these documents labeled LD technique, sorry, technique topics.
Yes, sir.
Oh, I think I just lost the connection.
Yeah, yeah.
So this is a probabilistic modeling technique, and as I just said that the idea is to find out the number of topics in a given documents or collection of documents, which can be used for clustering in very
Sorry,
niche
sir.
sense. If you have
Sir, your
idea for
voice is not
like,
voice is breaking, sir, and presentation is also not visible.
okay, just a minute, I will change the network. So it is like am I audible?
No, sir. Still voice is breaking.
All of that is a problem. Like I am not audible to everybody, or is it some people? Can you just hello?
Yes, sir. I think there is some network issue at your end. Or you can
Okay.
rejoin the
So
meeting, I think.
okay, I'll do this. Hello.
Yes, sir.
Is it fine? And now I'm audible?
Yeah, yes, sir. Perfectly.
So just a quick recap, I was saying topic modeling is nothing if somebody gives you a collection of documents and then asks you to find out how many topics are there. So using topic modeling techniques, you will be able to find it out like how many different topics are available. And this is abstraction of the topic. So topic will not come in the form of politics. It will say topic one is available, topic available, it is some integer number. How we do it, this is like falls into the probabilistic topic modeling technique. And I will just go into, I will discuss one of the model under this probabilistic models, which is known as latent Dirichlet allocation. And it is an unsupervised technique.
Sir, please share your presentation.
Okay. I don't know, something happened at the last moment. Visible? Is it visible?
Yes, sir. Now it has started sharing.
I hope my screen is visible now. So can I start? Somebody type me and let me know like whether I'm audible.
Yes.
Fine. Okay. So then, as he said that it falls under the probabilistic topic modeling technique, and the good part is that you don't need to label the things. It comes automatically. So this labeled latent Dirichlet allocation technique comes under unsupervised category, and you just save a lot of effort from annotating the documents manually. And this automatic approach will automatically find it out how many topics are available in the documents. Right. So as I said that there are so many models available, but one of the model is related to Dirichlet allocation. And here the key assumption is that document is a distribution of a So let's say I have one document, and that document can be seen be seen as a distribution over topics. For example, you may take a newspaper, and that newspaper may have different topics available in it, like politics. So if I just present it, let's say I take three topics: topic one, topic two, topic three, and topic one is newspaper. This topic one is being discussed like 7% time, and 25% time this sports are being discussed, and 5% time, let's say, some international news being discussed. So this document, there are three topics involved, and 70% of the time, like if you find out what is the distribution of topics on this document, so you say 0.7 is like Bollywood, 0.25 is politics, and 0.05 is international. So it adds to like one. So the idea is that document can be seen as a distribution over a topic, and every topic can be seen as a distribution of vocabulary. For example, if you ask me like what is the topic one, politics, of which the word that is being used so many times, so the probability of the coming BJP and Congress is very high here in this in the vocabulary, and if the probability of bringing tea or a river is very less, right? So just a minute, I just lost something. So I was saying that the document, you can see that there are two key assumptions. The document can be seen as a distribution over a topic, and each topic can be seen as a distribution of vocabulary, right? So let's say assume that vocabulary is fixed here. So now let's say we have to have 50,000 words, and these 50,000 words have a probability to appear in every topic, but the distribution will keep on changing. For an example, if bringing BJP word into the topic of Bollywood, the probability is less, and but BJP comes in under the topic of politics is very high. So you assume that there is a fixed set of vocabulary, and the distribution over these vocabularies will keep on changing by the as the topic will change. So here So if you take an example, this is the example that if you see, for an example, here I have taken three documents, document 1, document 2, and document 3. So, and there are two topics, topic 1 and topic 2, right? So if we see that document 1 containing only, document 1 is containing only topic 1, and document 2 is containing topic 2, 1 and 2, both 50-50%, and document 3 is containing only topic 2, right? So here we have three documents, document 1, document 2, document, and each of the document is containing some distribution over topic.
So
Here
please
topic 1 is with probability
share the
1 and topic
presentation.
2 is with probability 0. So, I don't know, this is getting disconnected every time. Just I think I have shared the screen. Is it? It is
Right
not
now it
visible.
is visible, sir. Yes.
I'm so sorry. I don't know today what happened. This network is doing very abstractly.
Yeah, in
So
online.
yeah. So there are three. Just to take a very concrete example, there are three documents: document 1, document 2, document 3, and there are two topics: topic 1 and topic 2. So here, document 1 is just containing only topic 1. Document 2 is containing topic 1 and topic 2, and document 3 is containing topic 2 only, right? So if somebody asks you, given these three documents, say that there are two topics, you need to find out only two topics, topic 1 and topic 2, and try to find it out which document is containing which topic. Then this problem comes under the inference, right? You need to infer this information from the data. So this is your data here, right? This is your data. So somebody has given you this document, that document 1, document 2, document 3, without telling you what is the distribution in these documents, right? Then you need to infer. And if you are ideally good in modeling techniques, then you direct infer that this document 2 contains 50% of topic 1 and 50% topic 2. Document 1 contain only 100% topic 1, right? It is just a percentage what I am writing. And document 3 contains 100% topic 2, right? So if your modeling technique is good, then you will infer this information, right? And as I said, that there may be hyperparameter. Hyperparameters means to say that somebody comes and tell you that there are only two topics that you need to infer. But if somebody is inferring three topics, then the things will get changed, right? So right now, just to make you understand, I have taken a very hypothetical example, putting that we know the topics, topic 1 and topic 2, and we need to find out what is the distribution over the documents, given three documents, right? So I hope this is clear to you. This is the example. Once this is clear to you, then rest of the things will fall in line. And please let me know just I'm connected or not. I'm connected, yes or no?
Sir, you are connected, but voice is breaking in between, and that is creating actually the problem because something is missed somehow
Okay.
in between. Sir,
Yeah,
I have a
I
question.
understand.
I have a question, sir. Because in three
Yeah,
documents,
yeah,
bank word is used in context of river as well as in context of money.
right.
So when we are summarizing or when we are making these reference inferences, then how we will be associate this bank with river or bank with money?
So it depends. Like this is very nice question. So if you know like what is the modeling technique that you are using, so you may not be using LDA every time, right? So as I said, there are so many probabilistic modeling techniques. So let's say you are using LDA. So what LDA do? It just sees the neighbors, all the rest of the words and find it out what are the topics they have taken. So for an example, in document 1, you are just want to find it out whether bank 1 is coming from topic 1 or topic 2. It means finance or a nature. And rest of the words have already taken their topics, right? So because most of the words have taken a topic from a bank, let's say from a finance, then this bank will also come from the finance. It is a probabilistic model, as I said. So it sees the neighborhood labels and find out the probability of aligning that particular word to which topic. You got my point? Hello, you got my point or not?
Uh,
So the things are like I will go over that. So if some words that you want to label it and find it out from which topic it comes, you see that what are the rest of the words in the document comes from. So if the rest of the words highly probable from the finance, then the bank will go to the finance. This is what it means, right? Okay. So for this, this is a generative process, and why we say it's generative process. For an example, with this assumption, if you want to generate your own document, how you can do that? So this is very important to understand. So let's say there is a distribution over topic. So I have a distribution, and this distribution is like it says that topic, let's say I fix, just for this example, I fix topic 1, topic 2 and topic 3. So it is topic 1, topic 2 and topic 3. But this is one distribution that topic 1 comes 50%, topic 2 comes 25% and topic 3 comes 25%, right? So this is one distribution. You change the distribution, it says topic 1 come 100 times and both rest of the topic will come 0 times, right? So there can be millions of or infinite distributions over these topics, right? So what we do in this full Bayesian technique, modeling technique, we assume that there is a distribution of a distribution, right? So we assume that you can take a vector of this 3 dimension, and this vector is always a distribution. So you can see here, this is a vector, right? And it is having 3 dimension. If you sum this vector, it is 1. This is also a vector. So you can say that there is a simplex of dimension 2, and you just take a point from the simplex, and this point is nothing but a vector, which is a distribution, right? So you are just drawing a distribution from a distribution, that is known as Dirichlet distribution. Once you pick a distribution, then you say, okay, my topic 1 comes 50% time, my topic 2 comes 25% time, and my topic 3 comes 25% time, right? In that case, then what you do, you just start producing a word. For every word, you just select a topic with the probability, because 50% is very high. So there are chances that this topic comes all more than the rest of the topics. And once you choose a topic, then you again throw a dice and find out in this topic which word should come. So for that particular topic, again, there will be a distribution. That distribution is known as multinomial distribution. So what is multinomial distribution? There is a k categories, and when you throw a dice out of these k categories, only one category will be there, right? So like a dice. So for an example, if I want to produce a word under a topic, so assume that there is 1,000 faced dice, and if the vocabulary size is 1,000, so that dice can fall onto any face, and based on the face, you will choose the word, right? So here, this is a generative process. First, you choose that which topic to come, and under that topic, which word to come. And likewise, you keep on generating these words. So it is important to remember. And if you see this is a graphical model here for this LDA. What it says that this is a Dirichlet distribution parameter. You pick a distribution for a topic, right? For that particular topic, you pick a this is a distribution of a topic. From that particular topic, you just choose randomly right now which topic you want to take by throwing a dice. And once you choose a topic, you will take what are the distribution of the words under that topic, and you finally take a word, generate a word on it, right? So here multinomial comes when you freeze the topic and you want to generate a word from that topic. So that's how you are just that's how you can see it as a multinomial distribution. For Dirichlet distribution, it is just to produce a distribution of a document. So there are, you want to produce a document. The document can belongs to a Hollywood or it belongs to a politics. It depends what is the distribution you have taken, and that distribution you are picking from a Dirichlet distribution, right? So just to see intuitively what is Dirichlet distribution, as I said that, assume that you are having 3-dimension vector, right? So this 3-dimension vector, and it is nothing but a distribution. How it can be a distribution? For an example, first dimension is 0.5, second dimension is 0.25, and third dimension is also 0.25. What is the chance of bringing this distribution? Who will decide like how frequently this distribution can be generated? It depends upon the parameter of alpha 1, alpha 2, alpha 3, which is a parameter of a Dirichlet distribution. So once you vary these parameters of alpha 1, alpha 2, alpha 3, it says that there is a very high probability of coming this distribution. Which is this distribution? It says, let's say 0.5 and 0.5 and 0, right? So because their third axis is 0 here. So it says that only two topics when come. One topic can be Z, another topic can be X, but Y topic cannot come because it is coming from this axis. The moment you change your alpha, your distribution's density will change because it is a density of a distribution. So here we are not learning alpha, but we freeze it for a Bayesian distribution, right? As the question has been asked to me, like how do I get to know whether the word is coming from a bank, the bank word is coming from a finance, or it is coming from a nature? So here we do Gibbs sampling for a Bayesian inference. What is Gibbs sampling says that, for an example, I want to do Gibbs sampling over this bimodal Gaussian distribution. It says first go to the x-axis and choose any number randomly. So if I choose any number randomly as per the marginalized distribution of x, this is the number. Then it says now freeze x and choose any number on y-axis as per the distribution. Then it says freeze y and choose on x-axis, and likewise. So every time you want to choose a point, you are conditionally taking a samples from it. How I am saying why I am saying conditionally? Because it is a bimodal distribution, and once you condition on x, you can pick y, and once you pick condition on y, you can pick x. And every time once you do, you are getting the dots. So these dots after 1000 times, what will happen? These dots will come as per the density of a distribution, right? So here, once you do 1000 times, you will find out a cloud that is actually reflecting the true distribution, which was the bimodal Gaussian distribution. So if it is this is just for your explanation. If you do it for 1000 for multi-dimension, then also Gibbs sampling comes into a play. But the only condition is that you can able to put a condition here, right? If you can't put a conditional distribution, then you can't run a Gibbs sampling. So here we have assumed independent identically distributed documents, and in that we have assumed IID words. So that's how we can do a Gibbs sampling over here, right? And once we do and infer it, finally we get to know document and what the distribution wording under the particular topic, right? So this is just for the naive understanding of LDA. But if now I'm going to tell you like how you can see this as a as application. So this is work that by me some 2-3 ago, and I want to discuss it because this related Dirichlet allocation this usage. So quick check, I'm connected. No. Yes. You can type. Okay, fine. Thank you. So just see here. So if you have not, if somehow you skipped it or because of a poor connection, if you skipped till here, that's no need. So far, I have just told you that the probabilistic modeling technique known as LDA. What it do, LDA assumes that there is a, if I give you a document, in that document, there could be a distribution over topics. And for every topic, there is a distribution of words, right? This is what I have just said. Using, if I run the LDA, I will find it out for a given document, what is the distribution of a topic over it. That's it. And for a particular topic, what I will find it out what is the distribution of a word over it. So let's take the example. What did we just try to find? We just developed a recommendation system for because this tweet is having a rich information. So we thought that why not to explore this? Why not to explore it? So we have taken, uh, we have downloaded some 500 million tweets and you are LDA for it, right? So just to understand why motivation was Twitter is rich resource of information. People share intent and interest. Intent and interest means like they generally what they feel, what are their moods, what their likes and dislikes. They generally share on the Twitter. And if we can use this information somehow for the modeling or for this information somehow we can use it, then we can just develop a recommendation system which will help the people to understand it, right? So the main idea behind it here is we were not having, we were not knowing like what people are writing for what, because it is just a textual sentence. And if people are writing that I like Narendra Modi or I want a food that is, I want a cafe coffee date nearby me. So there are no ways to just understand semantically these short sentences, right? Or tweets, because tweet is just 15 word character sentence and which is having a very short information in it. So what we have thought in our mind that we will be using this Twitter tweets just to recommend a places for a user which are nearby in the fraternity. For example, you are standing somewhere and you have written something on your timeline in last 1 year. So we will be using that information and we'll be telling you like, okay, if you are this type of person because you have used a word based on your vocabulary, we'll be trying to find out your intent and mood and try to recommend a places nearby you. It may be a restaurant, it may be a theater, movie theater, right? So the challenge here was like how to know what are your likes and dislikes. So what we did, we have just scrolled the tweets and that tweet was not labeled actually. So we found out if there are any mentions of places in that tweet. So if you say that I am at barista, so we have taken a word barista and found out that it is a name of a place. Just to validate it, what we did, we using Google Places API, and using Google Places API, what this GPA do, Google Places API, it returns 50 places or 100 places in a nearby coordinate. So when you tweet it, so geo coordinate will come with the tweets. This geo coordinate location will come to this we will feed to this GPA. Around this location, this GPA will return some 60 places, right? Some 60 places around this location where you're from, where you're tweeting. If you have used that I am at the barista and this barista is among these 60 places, so we found out that you are actually telling a lie, you're not faking it, right? So this is the way we have validated it. Now by this we found out that we tagged every tweet with if you're saying that barista, you're saying that I have taken a Pepsi, or I like Shah Rukh Khan movies. So we found out that based on your location, if you're saying that I'm seeing Shah Rukh Khan movie at this theater, so based on your information and based on Google Places API, we found out that if the places are matching, then we tag that you are at that place, and this tweet is not fake. Just validate it, right? And this is just a sample of it. For an example, if you're saying that hi Jay's 40 at the rate 4040 club, right? So we found out that because this at the rate symbol is being used for a places Twitter by a user, so we have taken this 4040 club and we have taken this geo coordinate of this tweet. This geo coordinate this geo coordinate will be fed to the Google Places API. What Google Places API will do, it will give you 60 places around this coordinate, and the places was actually 4040 club, and we matched this condition, right? Because this condition is we said that this guy is actually telling lie and he was actually at 4040 club, right? For an example, about to smash at white rose system, right? So we have found out on this date whether there is a white rose system around this coordinate or not using UGPA. And if it is there, then we say that yes, this guy was there and he was actually, this tweet is not fake. For our purpose, what we did, we just crawled some 14 million tweets. We have just extracted these things. We have just extracted only those tweets which were having a geocoordinates. Then we found out that these geolocations are repeatedly coming again and again. So what we did, we just found out the unique geolocations, and out of the unique geolocations, we used those unique geolocations for GPA, and we tagged it. So the number of users we found out are 4,600, which were actually labeled by this technique, right? So the intent was like, if you write that I am hungry, so it means that hungry word is somewhere correlated to your restaurant, and you keep on repeating, typing this thing on your or on your tweets, in your tweets, that I am hungry. So we found out because you're hungry, it is better to recommend some places around you which are restaurants, and based on your taste we can do that, right? So the hypothesis is that the words that you are using, these words may have a very good correlation with the places that what you are going to use in future, right? So in the proposed approach, what we did, we just, because we have taken places from Google, every Google Places API will be labeled by a category, right? So this was a category 1, category 2, category 3. For an example, if you say I am at Max, so if that Max is actually labeled verified by Google Places API, then Max is having some categories: category 1, category 2, category 3. So Max can be a video, Max can be a restaurant, it can be a video theater, or it can be some place for hangout. So we have some 100 categories for every places, and we labeled those categories with the tweet. So all those users which have somehow written that I am at barista, so we have labeled that tweet with the categories that are available at that place. For an example, barista is a restaurant, it is a coffee day, and because it is not a it is not a theater, so the only labels which are correlated to the place were labeled. So it is a multi-labeling problem. So multi-labeling problem means it is a supervised problem with the multi-labels. It may be possible that, for example, if I show you a photo and I ask you whether it belongs to a boy or a girl, so it is a single label, right? But if I give you a newspaper and ask you, what do you think this article belongs to? That article belongs to so many things, right? It can belongs to a politics. It can belongs to sports. Similarly, the place can belongs to a multiple categories. For an example, as I said that this Max can belongs to a theater. It can have a restaurant in it, and it can be having some recreation centers also. So the intention was that we have labeled a tweet with a lot of categories, and once with this multi-class classification problem is there for us, and we need to predict the labels based on the words used by the users, right? And there is a huge literature available. One of them which says that the words which people use actually have a latent factor which can tell your age, sex, person, and what are your intents, right? So based on the vocabulary, we try to find out what are your mood and where you can go in the future. This is all about. So what we did, we just crawled a timeline of a user, and he may be having some tweets which are tagged as by using Google Places API. So for an example, this tweet, so these all vertical arrows are tweets basically. So let's say here he says that I am at ABC, right? So this is a tweet, and he said I'm at ABC. What we did, we taken just some 20 tweets previous to those tweets. So let's say that this guy has tweeted at 10 a.m., right? This tweet at 10 a.m. So we have taken 20 tweets before 10 a.m. And now all the contents, what is available before the tweet, which when he was about to say that I am at Barista. So we have taken 20 tweets before that tweet. He may be saying that I am hungry and I want to have a coffee. I want to go, some friends come on. So there are 20 tweets which we have taken. And out of those 20 tweets, we found out that the mostly this tweet is correlated to some restaurant, and he will go to a restaurant based on the geo coordinates where he will be at that time. We will find out the places, and out of the places which are the restaurants we are predicting, we are saying that you can go to this restaurant, right? So this is how we have extracted the features. And once we did that once we extracted these features, so we did what we did, like we formed a training and testing data set. So there are two things here that are very challenging. First, it is a multi-labeling problem. So multi-labeling problem, and the other is like we don't know what are the intents in that in the word. Hungry means something for humans, but hungry has some intention that human can understand. But how can a statistical model that understand it? So we have to find out the intent in a word, and once we found out the intent, how to classify it for a multi-labeling problem, right? So as I said, just to recall the things, as I said, there is a timeline from a user one, right? He have said so many times, like I'm just the timeline from, let's say it is 1 a.m. in night, and this is current time 1 p.m. in day, right? 1 p.m. in day. So you have tweeted at 1 a.m. night that tomorrow I will go to some restaurant. In morning you say I'm jogging but I'm really hungry. Then I say, hey friends, do you want to hang out? Then he says something like related to that my college is there till 2 a.m. And finally he say that I am ready to have some snacks now. So now once at this time he say that I am at the barista, right? This time he say I am at the barista. What we did, we have taken all these tweets, and using these tweets we predicted whether he will eat something at 1 a.m. or not, right? So we have validated it and found out that yes, our technique work. How to do that? So as I said, that we have discussed latent racial allocation, which is nothing but it is a distribution of a topic, and for each topic is a distribution of a word. Here I said that my categories are fixed. So in latent racial allocations, my topics were not fixed, and I can have any number of topics like 100, 1,000, 1,000, and you have to freeze it for a hyperparameter. But in labeled LDA, my categories are fixed. As I said that every tweet was labeled by some categories, and these categories can be restaurant, theater, sports complex, like any So there are total 100 categories we had. So what we did, we had used another version of label LDA that is known as labeled LDA, right? Latent dirichlet allocation, labeled latent dirichlet allocation. What it says, so how it is different from LDA? LDA was saying that there is a distribution of a topic, and from every topic you are choosing, from a distribution of topic, you are choosing a topic, and for that particular topic, you are choosing a word, right? This is how you are forming it. Here you are saying that, okay, there is a distribution over a topic, but that these topics are not like any number of topics. There is a constant of a topic, and these topics are given by this phi. So here you say that there are only 100 topics available. So latent dirichlet allocation, label LLDA is different from LDA in sense of supervised learning. So LDA was unsupervised, and labeled LDA is somewhat supervised, because we know that there are some 100 categories in which you have to find out a distribution over topics, right? So my feature vector was like this. So I had a tweet, and these tweets were like some past tweets of a user, and each tweet was labeled with some categories. It may be like restaurant, complex, or theater, right? We have also used some additional constants. These additional constants are like radius. For an example, you are standing somewhere here, and I want to recommend you some place. So it should not be like I'm recommending some place which is 100 kilometers from you. So we have taken a radius constant, and we have said that you have to give a recommendation, but we did it in a 50-kilometer range, right? Then we have taken a second constant, time. For an example, if I want to recommend you something in morning, so it should be a coffee. But if I am recommending you something in night at 10 p.m., it should be some like pub or some restaurant where you can take a dinner, right? So time is also an important factor, and distance is also a factor. So we have considered these two things into a play, and taking time and distance, we have we have done an additional constraint over here. The challenge was like how to mingle this information and to recommend a category. Then the first was like, what is a category? So condition is, what are your tweets and at what time I am recommending to you, and the recommendation will be category, right? So it is a conditional probabilistic problem which I want to model. What you have tweeted in the past, and what is the time right now. Based on your tweets and based on your time, I will going to tell you, okay, because this is a morning time, and you have said that I just want to have a very nice mood freshener, and it is morning. So I can correlate it because you may be needing some coffee, or you may be needing some juice in morning. So based on your location, if it is in under 100-meter range, I find it out some coffee restaurant or some juice corner, I can recommend you that. It seems easy to understand and easy to see the things and understand the things, but really our challenging thing is how to implement this thing. So just for implementation, what we did, what we did, we have taken a past tweets just to find out what is your mood, and correlate those tweets with the categories where you can go, right? So we have run a labeled LDA over it. What labeled LDA has done, as I said, that each document can be seen as a distribution of a topics. In labeled LDA, we have said that there are 100 categories, and you have to find out a distribution over these categories, right? So for an example, I have taken 20 tweets. I fed these 20 tweets to a labeled LDA, and this labeled LDA will give you a distribution over 100 categories. And in these 100 categories, let's say the highest probability will be of restaurant, and the second highest probability will be of a park, right? So based on your 20 tweets, I found out a distribution over my topics. Topics are nothing, categories here. And I will choose first 5 probabilities, top 5 probabilities. And because these top 5 probabilities says that there is a restaurant that these words are correlated to, or a park they are correlated to, I will take first 5 preferences from the distribution and recommend to you that see the first preference to the first recommendation to you that you can go to a restaurant. The second preference to you that you can go to a park. The third preference to you is that you can go to a theater, let's say. Based on that, a person can choose based on his intent and upon his recommendation, because it will give you within a radius, right? You can be in 50-meter radius or 100-meter radius. So how to simplify? Then the challenge was, because we have a words from tweets, but how to mingle the information from a time. So we have done some Bayesian analysis, and we just sort out some Bayesian formulation and found out that if you want to condition some you have to condition words and on time your category recommendation. What you can do, you just find out the probability given by tweets, and you find out the probability given by a category at time, and you normalize it. So this part we have already found out using labeled LDA, right? Well, what labeled LDA was doing, it was taking your tweets and giving you out a distribution that you can go to these categories. That is labeled LDA is doing. The second part is this time where you can go. This is also like at morning you can go to a park, or at evening you can go to a pub. So this is a probability of a category at a given time. How you can modulate it, how you can estimate it. What we did, we have just taken every at a given hour of time, right? So we disguise time into 24-hour slots. So from morning to evening, there are 24 slots, let's say in 24 hours. And for every time slot, what we did, we just found out in that particular slot how many categories are visited by a user, right? And then we just normalize it and found out which are the categories which are more preferable than other categories, right? And this is again a distribution by time basis, on time basis. Fine. So now I have a category, my category estimate as per time. I have my category estimate as tweets, and I can multiply it and normalize it, right? So this is what we have done. So here is a proposed diagram which we have used. So we have feed our tweets to LDA. It will give some probability, which category I want to go. I give time and find out the probabilities where I can go at this time. We have mingled these probabilities using Bayesian analysis, and once I got probabilities of a category where I can visit, then I just do some constraint of a radius. You may be, your tweet may say that you can go to a restaurant, but there are no restaurants available in 100-meter range. Then the second category was that you can go to a theater, and there is a theater available in 50-meter range. Then based on this radius constraint, we say that you should not go to a restaurant because it is very far. You should go to a video theater because it is 50-meter range. And people generally fall for the things which are nearby, and they avoid those things which are far because of that jam or urban culture, whatever it is, right? So this is what the theme was. And now that what we have to do is, like we want to construct and model the problem using the feature extraction thing. So this is an example of number of locations shared by people on their time, right? So you can see here that there are very few people which are actually using location tweets on their timeline. And most of the time, because of privacy or something, they don't tweet with the timeline. They don't tweet with the geo-coordinate thing, right? So the effective data which we can use fall into this category, because these are the users which are frequently tweeted by the geolocation. What we did, we have taken those users on which have tweeted more than like 60 location tweets on their timeline, right? So there are, let's say 4,000 users we had. Out of 4,000 users, we take only those users which are having 60 locations on their timeline, and which and the rest of the user which are having less than 60 locations. So there were 1700 users which were having 60 locations on their timeline, and some there 3000 users which are having less than 60 locations. Now we had to form a features for training a labeled LDA. What we did, so there is a timeline, right? So this was a time. There are 60 location tweets. So out of 60 location tweets, we have taken 50 location tweets for training, and rest of the 10 location tweets we have used for testing, right? For testing. And for training, what we have done, for every location tweets, we have taken first 20 tweets and labeled it with the categories where he visited after those 20 tweets. For the second location tweet, we take 20 tweets before that location tweet and then labeled it where the category they have visited after those 20 tweets. Likewise, we have formed all those training samples. And for testing, what we did, we just taken a location tweet. We have taken 20 samples, 20 tweets before it, and then labeled, and we have hide those labels where he have visited, right? We have hidden those labels, and we are predicting those labels at the time of inference, right? So here it is shown that in training data we have some 2.6 million tweets, right? 260,000 tweets. And for testing, there are 84,000 tweets, and for testing data, 56,000. Where this testing data set 2 comes from? We have said that from these tweets, from this data set, where the users are greater than 60, we have taken training and testing data set. And for this test data set 2, where the locations are less than 60, we have used only for testing data set, right? Then, so how to evaluate it? So for every prediction out of the distribution, because the distribution was over 100 categories, we have taken only top 5 categories and try to predict it that the user may visit among these 5 categories. So 1, 2, 3, 4, 5, something like that. So if true ground truth falls on those 5 categories, we have said that yes, the predictions are right. And if my ground truth doesn't fall into those top 5 categories, I said that this is not a right choice, right? This is what we have done. Because this work was very new and we have done it first time, so we can't compare it with the state of art. So we have proposed our own baseline. So what we said, people used to prefer go nearby places. So let's recommend places which are very nearby, irrespective what they have tweeted. So this is my baseline model 1. In baseline model 2, because Google Places API always return a place with the Google popularity. So we have said that which places are popular nearby, we can recommend those. Then we just found out which category is popular in our data set, right? Third baseline. And fourth baseline, which category is popular time-wise. So there were the 4 baselines that we have used. And finally, when we compared it, we found out that our method is actually, which is taking tweets and time into consideration, is very high, right? And these are all the popularities which we have taken baselines, and they fall somewhere near. This second timeline, this second accuracy is for when we are taking only tweets, right? So we have said that when we take tweets and when we take tweets with time, so my result is being improved, right? My result is being improved. And the good part is here in test dataset 1, I have already seen the users, because this test dataset comes from the same users which I have used for the training. But in test dataset 2, the users are totally different. So we have shown that this methodology actually work independent of those users which were used in training, right? So it is very generalized basic model, very generalized. Fine. So then we just compared it to the baseline and found out that our baseline is actually working. Our proposed model is working better than baselines. And this is what we have found out in my labeled LDA model, that every time the user is tweeting these words in their tweets, So these words are actually tweeted before he has visited a restaurant. These words has been tweeted before he have visited to before he has visited to a place which is providing a food, right? These words are tweeted before he has visited to a movie theater, right? And these words are tweeted before he have visited to a gym or health center. And like where this is a place for worship, a park, and a shopping mall. So you can see here that these places are very high. These words are very highly correlated to the places where the people are about to visit, right? So, and this is what this correlation is captured by labeled LD, and we found out that it's really a very this probabilistic models have a very good application on text mining. If we found then we said that how many tweets we should consider, right? Like people say that you should consider 20 tweets, or then you say that 10 tweets. So we thought of that, why not to consider my tweets as per time, right? So we said that leave the number of tweets. We will be using only those tweets which are tweeted 6 hours before, or 12 hours before, or 24 hours before, and 36 hours before. When we did a lot of experiment and found out that when we take tweets only which fall under 12 hours, they have a highly correlation to our better prediction. Why? Because if you have used some tweets which being tweeted 3 days before, it doesn't have any impact on your current visit. But if you are using a tweet which is like tweeted 3 hours before or 4 hours before, then it is having a real good impact because it is very near in recent near time. And we found out that when we predict the tweets using 12-hour window, it will always give us a better result in both cases, right? Then this is for like different radius. We found out that for radius 300, we always get a better result in all cases, right? Whether it is for category versus time, and for both times, for both test data set, test 1, test 2 data set, right? And the reason is because the radius 300 is like approximate radius where a person can walk also, right? And once the radius is 1,000 meter, and it is like I am suggesting somebody to you should go visit a restaurant which is 1 kilometer away. We found out in our data set that the users be very less preferable for the far distances than the near distances, right? In that case, our results show that the users for recommendation systems always prefer near time, which is obvious, and close to the proximity, right? But we have validated it using our this microblogs data set, and this is first of a kind, which was like which got published. So we have published in some knowledge information system, and there are 2 conferences on this work. It is available online. Please, if you want, if you're interested in it, then go it. I have done this work in IBM Watson with Krishna Komamuru. He's right now like with Accenture's AI intelligence head. And yeah, so are there any questions? I really apologize. I know that the network connectivity is bad and it was not active, but still, whatever.
Hello.
Any questions, participants? Yes.
Hello, sir. Am I audible, ma'am? Uh,
Yes, you are audible.
Yeah, you're audible.
I want to ask one question. Is there any limitation for LDA,
Yeah.
or can the correlation be handled by LDA at some particular time?
So limitation is like because it is computationally expensive. So the thing is, if you have like millions of document, it take times. It take a lot of time to get like trained. But recently, after this, recently you just follow the work done by David Bly from Columbia University. He's like a pioneer in this field. He do the every time new. So he has just proposed recently some new models which are computationally efficient. The code is available. You need to plug and play those things, and it will correlate the things. So the question is like, if you run LDA, you can do unsupervised learning. You can cluster the documents, right? For example, I
Okay.
have some million documents. I want to run LDA. So every document will have a vector, which is a distribution. Then I will just find it out which vector are close in proximity in Euclidean distance, and it will like clustering, right? K means clustering. So all document which are very similar, they have a same distribution, and you just compare the distribution itself rather than the document, and that will help in clustering. I have done labeled LDA. You may, because of the poor network, you may skip the thing. So labeled LDA is a supervised version of a LDA. So here my documents were fixed. In LDA documents, my topics were not fixed. Sorry. In LDA topics were not fixed, and labeled LDA topics are fixed. So I have used 100 topics only given. So they were given. So did I answer
Okay.
it? Because,
Yes, yes, yes. Can it handle correlation
oh, yeah,
in
obviously.
the
So if
parameter?
you just see if you see this part, so this is we have got a good result only because it handles a correlation, right?
Okay.
Because
Yeah.
statistically, lunch is correlated to a restaurant, right?
Yes,
And
yes.
this dinner is correlated to restaurant, so it always handles a correlation. And the good part is the more you train it, the highly correlated words will come. They will come. They will surface out.
Yeah, okay. Yeah, thank you, sir. Due to some network problem,
So
meanwhile, I missed some of the PPT. Yeah, yeah, no issues. Sounds good now, sir. Thank you.
I will share this PPTs.
Yeah, yeah, yeah. Thank you, sir.
Right.
Uh, Sir, there is one question in chat box.
Uh-huh.
Can we use LDA for short text topic modeling?
Right. Obviously, this is what we have done. We have done on tweets. So tweet is just a very short text. So tweet is just like, I still remember it is some 150 characters. So like hardly you can use 15 words. It is just one line, right? So we have done it on a short documents only. So all those documents which we have used, for me in my work, the document was tweet, and tweet is very small, very small sentence of 15 words. So yes, the answer for your question is yes, we can do it.
Any other questions? Sir, we have recorded your session. So if possible, we can share it to the faculty participants through YouTube.
Fine, man. I mean, if the quality is good, I think then you can do it.
We can see to it. We will be covering the important things, right? Okay, sir.
Fine.
Yes,
Thank you.
Nankishore sir, you,
Yeah, yeah,
yes.
ma'am. I'm trying to unmute actually. There's some problem in.
Yeah, yeah, please.
Right, okay. So, any other questions, faculty participants?
Hello, am I audible, ma'am?
Yes, sir.
Sir, I have a question that you have taken two parameters like radius and the time.
Right, right,
Uh,
right.
we can also take the age of the person, or then we can also take hobby, like preferences of the person also.
Right. So very nice. Thanks for bringing this point out. So the other very advantage of our work was like which we have just highlighted in our paper was we don't need to see the demographics. So here we don't need to see the demographic of a user. So we are just using only words. But yeah, you are very right. If somehow you get additional information of a user, we can always get it. And I am very much sure that we will improvise the recommendation accuracy.
Thank you, sir.
Yeah. Okay. Thank you.
So yes, if there are no more questions, we will like to end up the session. So faculties, if there are any other questions. Right. So Dr. Arun sir, I am very much thankful to you for sparing your time and sparing your valuable resources. Please share your PPT with us so that at the last day there will be assessment. So faculty members will go through it. And you know, during one particular session, as there were so many sessions and a flow was continuously made, so even there are some faculty members from the multidisciplinary courses. So this LDA and LLDA, which was explained by you through a very informative example, so it is a very nicely delivered lecture and with a clear understanding on such an important topic like topic modeling. So definitely people have enjoyed it.
Thank you very much. Thank you. Sir.
Once again, thank you very much, sir. Right.
Thank you.
So all the faculty participants, you are please requested to fill the Google form for the attendance link. We have seen that even in the previous days, you may have attended, but you have missed out. That document is to be submitted to AICT and only then it will be counted. So at least for today, just remember to do it in a timely manner. In the afternoon session, we have a very informative and again demonstrative session based on automatic speech recognition. So already all the installations have been shared with you. So if possible for some of you, be ready with the systems, or we will request the expert to share the things. And please join at 2 p.m. for the afternoon session. Already we can understand that it was a very rigorous program, but kindly bear with it. Tomorrow at 2:30 we will be having multiple choice question quiz that will be conducted through portal only, right? So rest of the instructions will be shared to you timely. Even we have not received all the instructions from AICT till now.
Good afternoon, ma'am.
Right. Good afternoon, sir.
Ma'am, today morning session, last moment I